In this video, we'll talk about union and intersection of sets. Well, the symbol for union is U, just from the word union, and the intersection symbol is an upside down U. Now, union means everything together, so bring everything, so union, everything, while intersection means just the common elements. So let's take a look at this example. The first example. Let A equal the set with the elements 1, 2, 3, 4, 5, 6, 7, and B with the elements 2, 5, 7, 9, 10, and 20. So we have these two sets. We want to find A union B. So we want to put everything together, and if they repeat, we just write them only once. So it's 1, 2, 3, 4, 5, 6, 7, 9, 10, and 20. So I wrote all the terms that were in A and in B, and I wrote them only once. Like, for example, you see 2, it's here and here. I wrote it only once. The second problem is A intersection B. So the intersection is the common terms. So I see 2 in A and I see 2 in B. I see 5 in A and 5 in B. 7, 7. So the three terms that are common are 2, 5, and 7. And that's A intersection B. Now, in terms of visualizing graphically, well, I want you to look at these two Venn diagrams. So I have the set A with black and the set B in red. There is also a common part, this part where they overlap. So in this part, we're going to put the intersection, the terms that are both in A and in B, 2, 5, and 7. And then this part here, the whole thing is A, while the part that I'm highlighting only with blue, it's elements that are only in A. So 1, 3, 4, and 6. While the part that I'm going to highlight in green, 9, 10, and 20 are elements that are only in B. So in terms of sets, we can visualize them in these Venn diagrams. Like, for example, the first image is showing you the set A, the image, let's call it 1, 2, 3, 4, 5, and 6. The second one, it shows you how they have nothing in common. Those are two disjoint sets. The third one, it's showing us the intersection. This blue part is the common part. The fourth one, it's showing the complement of A, what's not in A. So everything that is not in A, it's highlighted in blue. 5, it's an example of B. It's a proper subset of A, which means B is included in A. So for example, if A is 1, 2, 3, 4, 5, B could be something like 1, 2, and 3 because it's included, like all the elements from B are elements of A. And then the 6th graph, it's showing A union B, everything that is in A and B. Now this is with sets, right? This notation and enumerating them like that, the numbers are sets, these are discrete values. So 1, just like these are 5 numbers here, while here I have 3 numbers, so they are discrete. But let's take a look at how the sets or how the intersection and union are going to look like for interval notation. So first of all, here in here it's the number line, right? It starts with negative infinity, positive infinity. It has a 0. It has positive numbers, negative numbers. I also represented some decimals here. So let's see. Write the inequality symbol between each pair of numbers. So 5 less than 7. That's the symbol. 1 over 2 and 1 over 3. Well, how am I going to decide this? Well, I can either approximate like 1 over 2 is 0.5, while 1 over 3 is 0.3 repeated. So obviously 1 over 5 is greater than 0.3 repeated. In the next problem, 2 over 9 and 3 over 7, I can either do the same, divide the numbers and find the decimal, or I can bring each number at the same denominator. So the least common denominator is 63, so I'm going to multiply the first fraction by 7 over 7 and the second one by 9 over 9. So I have 14 over 63. Compare it with 27 over 63. So because 27 is larger, 14 over 63 is smaller than 27 over 63. The fourth problem, 0.3, compare it with 0.333. Well, when I have decimals and I want to compare them, I want to have the same number of decimals. So here I have 3 decimals, so that means I'm going to write after 3, after these 3 here, 2 more zeros. So now I can easily see that I have 0.300 and 0.333. So the second number is larger than the first number. And then the last problem, -3, compare it with -4. Well, the negative numbers, as they are closer to the origin, they are larger than the ones that are further away. So -3 is greater than -4. And you can think 3 is less than 4. So if I multiply by a -1, I get -3 and -4, and we have to switch the sign. So here you have a table that it's explaining every single set. If we have a set x with the property that x is greater than a, then in interval notation it would look this way. It would look a to infinity, and if you want, we can graph it like this. Number line, we put a here, and we want to represent all the numbers that are greater than a, so we shade greater than a, and we put parentheses because it's strictly greater than. So when we write the interval, we write the 2 endpoints, which are a and infinity. The second one is x with the property that x is greater than or equal to a. That means when we go to a, because it's greater than or equal to, we put bracket and we shade all the numbers that are more than that. So in interval notation, we would write a with bracket infinity. At infinity and negative infinity, as you notice, we always put parentheses. We never put brackets. And so on. Please look over every single one of them. Let me emphasize on this one. A is less than or equal to x, less than b. Now, how I would draw that, I would put a and b on the number line. Because x is greater than or equal to a, I will put bracket, and is less than b, I would put parentheses and shade in between them. So as you can see, this is what the interval became. So you can go and draw all of them, or look over them, how they are written in interval notation. So let's do a few examples. It says, let's find, for the first one, we want to find the interval, the negative infinity 4 union -2, 1. So for first one, I'm going to draw them on the number line, negative infinity, positive infinity. Then I'm going to put the numbers in order, so -2 first, 1 next, and 4 next. And I'm going to highlight what is negative infinity to 4. So negative infinity 4, let's put parentheses, and let's shade all that region that is negative infinity to 4. Then we have the interval -2, 1. So, and -2 is parentheses and 1 is bracket. And we want, and we shade that. And we want the union. So we want everything. Now, what do I see shaded in this picture? Well, I see all this shaded. So now I'm going to write the endpoints, negative infinity, all the time parentheses at negative infinity, and it stops at 4, which ends in a parenthesis, so the union is negative infinity 4. Now let's try to do problem 2. So problem 2 has again negative infinity 4. So negative infinity, positive infinity. We put 4 here, and we can shade all this region with parentheses. And then negative 2, 1, again with the appropriate parentheses, and we shade it again. So I could shade the region in between with red. So now, because they ask for intersection, so the common part, I'm gonna look for the interval where they overlap. So where I have black shaded lines and red ones. So that would be in here. So the intersection is negative 2, 1. All right, and let's do one more. So I'm going to do 4 also. So let me plot the points: negative infinity, positive infinity, negative 5 over 2, that would be negative 2.5. So negative 5 over 2 would be here, negative 1 would be here, 3 would be here, 9 over 2, that's 4.5. So I'm going to put it here. So now negative 5 over 2, 3 would be this interval, and I'm going to shade it with black. Negative 1 and 9 over 2 would be this interval, and because they have parentheses, I'm going to do that too. And the region or the interval is shaded with red. Because I want to find the intersection, well, I'm going to look for the part where the black and the red overlap, and it would be between these 2 points, which are negative 1, 3, with parentheses. So try and do 3 on your own. Let's do one more for fun. So let's call this 5. So what if you had to find the intersection between negative infinity 2 intersected with 5 infinity? Let's say we had this problem to do. So 2 would be here, 5 would be here. Negative infinity 2 would be this. And I want to intersect it with 5 infinity, which would be this. So do they overlap? Do I have... Let me represent 5 infinity with red. Do they overlap? Do I have the black interval with the red one overlapping? Maybe this one is not. Do they overlap? Well, they don't. So what does it mean? Well, when they don't overlap, we get empty set. What if we had this problem? Let's say we had negative infinity 2 union 1 infinity. So negative infinity, positive infinity, negative infinity 1 and 2. So negative infinity 2 would go this way, right? And negative and 1 infinity would go this way. I have to do union, right? Union. So union means everything. Well, what is everything shaded? Well, everything that is shaded is from negative infinity to positive infinity. So basically this union would be the whole real number interval, the interval of all real numbers, negative infinity to positive infinity. If the same problem was intersection, then the part where they overlap would be 1, 2. Now, what does it mean, interval 1, 2? How many numbers are between here? Well, it's not just 1 and 2. Actually, not even 1 and 2, because we have parentheses, so it's not included. It's coming very close to that point. But we have 1.1, 1.001, 1.0001. So we have infinitely many numbers in between those. So they are different than 1, 2, where I see just 2 numbers. I hope this helps.